This is a key to the worksheet dealing with topic 5, part B. And part B is the one where you had these quadratic equations, and you want to solve these quadratic equations, but the way you want to solve these particular quadratic equations is to use the square root property. And the reason you want to use the square root property because it's in that form. It's in the form where you have some expression squared equal a number. So whenever it looks like this, some expression squared equal a number, which is what you have here, some expression squared equal a number in all these cases, then the best way to solve this is to use the square root property. Okay? And remember, the square root property said this. It said if I have a squared equal b, so I have some expression squared equal a number, all right, then to get a by itself, since I'm squaring a, the opposite of squaring a is to take the square root. So I'm going to take the square root of both sides. But one of the things you learned in these lessons is that when you take the square root of both sides, you get a plus or minus. So that means that when the square and the square don't do each other, your solutions for this original equation was the plus or minus the square root of b. Okay? And that's the idea you're going to use here. So in number 1, let's look at number 1. We have, all right, so let me write down number 1. So number 1 was this. You had 3x minus 2 squared equal 16. Okay, so notice I have this quadratic equation. This is quadratic because if you were to FOIL this out, you would get a quadratic equation. 3x times 3x is 9x squared. All right, so you get this quadratic equation. So remember, a quadratic equation has this form, ax squared plus bx plus c equals 0. It has that form. That's the form of a quadratic equation. And so in this particular case, if you were to multiply this out, you would get something that looks like this. But you don't want to do that. You don't want to multiply this out. You want to use the square root property to solve this because it is of the form some expression squared equal a number. And so let's go ahead and do that. So when I do that, let me go ahead and rewrite it. So I get 3x minus 2 squared equals 16. And so I'm going to take the square root of both sides. Don't forget the plus or minus. And so the square root and the square root undo each other. So you're left with the radicand 3x minus 6. Or you're left with the expression 3x minus 2, excuse me. Equal. Now here's where you have to be a little bit careful. And notice that 16 is a perfect square. And so the square root of 16 is 4. So this right here becomes plus or minus 4. One of the things that you learned in the lessons was that for this equation, now that you see what it looks like, there's no square root any longer because this was a perfect square. Your solutions are going to be rational solutions. Solutions are rational. Since the solutions are rational, you're going to split it apart like this now because you want to indicate what those rational solutions are. And so we get 3x minus 2 equal a positive 4. And this also says that 3x minus 2 equals a negative 4. That's what that says. And so notice that I went from a quadratic equation to 2 linear equations. And so to solve this linear equation, let's go ahead and add 2 to both sides. So I get, when I combine like terms, I get 3x equals 6. Divide both sides by 3. Reduce, I get x to be 2. All right, so that's one of my solutions. And you can check it real quick. Let's check x equal 2. Watch. 3 times 2 is 6. 6 minus 2 is 4. 4 squared is 16. I saw that? So to check, you just go back to the original problem, and wherever you see the variable x, you substitute 2. And so I'm just going to go ahead and write it down right here. Now you don't have to check, so just keep that in mind. But if you wanted to, you would check x equal 2, and I'm going to check just one of them. So you would say 3, always go back to the original, so we'd say 3 times 2 minus 2 squared, and you want to see that's going to equal 16. Well, 3 times 2 is 6. 6 minus 2 squared becomes 4 squared, which is 16, and that's what you wanted. Okay? All right. Now, the other one was this. So now you're going to add 2 to both sides here. So I get 3x equal a negative 4 plus 2 is a negative 2. Divide both sides by 3. I get x to be negative 2/3. And so those are your two solutions. Okay? And so those are rational solutions. Remember, one of the things you learned many years ago was the idea of what rational numbers are. So these are rational solutions, rational numbers. 2 is a rational number. Negative 2/3 is a rational number. All right. So whenever you use the square root property and this number right here is a perfect square, you will end up with rational solutions. And so then you got to split it apart like this. All right. So that's how you have to work this problem. Number 2, we have this. So number 2, we have 4x plus 3 squared equal a negative 25. All right, so 4x plus 3 squared equal a negative 25. Now, let me go ahead and rewrite this over. So 4x plus 3 squared equal negative 25. And remember, he's trying to solve for x. Well, this quadratic equation is of that particular form, so have some expression squared equal a number. Now, the problem in this situation here is that this number right here is negative. All right, but we know how to deal with square roots of negative numbers. Okay, so let's go ahead and take the square root of both sides, just like this. Don't forget the plus or minus. And so the square and the square root undo each other. So I get 4x plus 3 equal plus or minus. Now remember, the square root of a negative 25, square root of negative 25 is the product of the square root of a negative 1 and the square root of 25. And because negative 1 times 25 is a negative 25. And we know that the square root of a negative 1 is defined to be I, and the square root of 25 is a perfect square, so that's 5, and so this becomes 5i. So this becomes plus 5i. Okay? All right, now, notice that this time my solutions are going to be imaginary solutions. So you're going to have complex imaginary solutions because of that I. And so there are a couple ways you can write this. Okay, so notice that when we did the previous one, I split it apart, just like this, and I got my 2 rational solutions. Now, you can do that. In fact, on my math lab, they're going to want you to separate your solutions using commas. So in my math lab, I just want you to know this is what you may need to do. You may need to say, all right, so I'm going to say 4x plus 3 equal a negative 5, or positive 5. Let's do 5i. And then 4x plus 3 equal a negative 5i, just like we did here, just like this. And so subtracting 3 from both sides, I get this. I get 4x equal a negative 3 plus 5i. And then to get x by itself, I divide both sides by 4. And so this becomes x equal negative 3 plus 5i divided by 4. All right. Now, the directions did not say anything about putting this in standard form. Remember a plus bi? So you can leave it like this. So that's one of your solutions. The other one, do the same thing. You're going to subtract 3 from both sides. And then when you combine like terms, you get 4x equals a negative 3 minus 5i. And then divide both sides by 4. I get 4 divided by 4 is 1. 1 times x is x. So I get x to be negative 3 minus 5i divided by 4. And so that's your 2 solutions. All right, so my math lab, you're going to have to say it like this. So this will be my math lab. So my math lab, you're going to have to say negative 3 plus 5i divided by 4, comma, negative 3 minus 5i divided by 4. All right. Now, here's on a worksheet or a test, then you can just do this. Let me show you what else you could have done. So at this point, you could have done this. So this is problem number 2. All right, so at this point you could have said, all right, I have 4x plus 3 equal plus or minus 5, I. And then instead of splitting it apart like we did here, let's go ahead and just do this. So subtract 3 from both sides. All right, now you got to be careful at this point. Remember, these are not like terms because this does not have an I. So you have to write it like I'm about to do. You must say 4x equal negative 3 plus or minus 5i. Negative 3 plus or minus 5i. You must write it like that because those are not like terms. This has an I, this does not. And then all you do is divide both sides by 4 and you're done. That's your answer. You have your 2 solutions. Those are your 2 solutions. Negative 3 plus or minus 5i over 4 divided by 4. So you can write like this, or if you want to, you can do like we just did a while ago. You can say negative 3 plus 5i divided by 4, or I can say negative 3 minus 5i divided by 4. Okay, so either one of those is fine. All right, so that was problem number 2. So let's look at number 3. So number 3, we have this problem in number 3. All right, so we have 2x minus 3 squared equal a negative 10. 2x minus 3 squared equal negative 10. All right, so just like we did with the previous two, you're going to take the square root of both sides. So you use the square root property. So I'm going to take the square root of both sides, plus or minus, don't forget the plus or minus, the square and the square root undo each other. So I get 2x minus 3 equal plus or minus the square root of a negative 10. Now remember, it's negative, the radicand's negative. So we have to remember that the square root of a negative 10 means the same thing as the square root of a negative 1 times the square root of 10. And the square root of negative 1 is defined to be I. So square root of 10, I cannot simplify the square root of 10. There is no perfect square other than 1 that goes into 10. So the square root of 10 cannot be simplified. And so that's how you write it. Now, whenever you still have a square root in your expression, put the I in front. Put the I in front, because this is what some of you are doing. So this is going to be wrong what I'm about to write. So some of you are doing this. Some of you are saying that this means the same thing as this. You see, you're putting the I underneath. The I is not underneath the square root. The I is outside of the square root. It's not part of the radicand. So don't do that. So that's why in the videos we emphasized that whenever you have imaginary solutions and there's a square root still in your answer, put the I in front. So this right here becomes this now. 2x minus 3 equals plus or minus I square root of 10. And then now what I'm going to do, just to make things a little bit better for us, I'm going to use this approach here. All right, so I'm going to say, all right, I'm going to add 3 to both sides, just like that. And so combine like terms, I can combine these. That's 0. So I get 2x equal 3 plus or minus I squared root of 10. Okay? And then to get x by itself, you just divide both sides by 2. And so you found your solution. So my solutions are 3 plus I squared root of 10 divided by 2. And then 3 minus I squared root of 10 divided by 2. Okay? Now, on MyMathLab, though, MyMathLab, you cannot write it like this. MyMathLab, you're going to have to write these as two separate solutions. Two separate solutions. So MyMathLab, you must say 3 plus I squared root of 10 divided by 2, comma, and then 3 minus I squared root of 10 divided by 2. Okay? All right, so that was number 3. And then let's go ahead and look at number 4. Okay, so in number 4, we have this. We have this quadratic equation, 3x plus 2 squared equal 12. All right, and then let me go ahead and rewrite this over. So 3x plus 2 squared equal 12. We're going to take the square root of both sides. We're going to use the square root property to get the expression by itself. So right now I'm squaring. The opposite of squaring is square root. But what you do to one side, remember you do to the other. And don't forget the plus or minus. And so the square and the square root undo each other. So I get 3x plus 2 equals plus or minus the square root of 12. Now this time, notice there's no negative here, so don't put an I. There's no I. Okay, now what I want you to notice though is this. You remember when we talked about the square root of 10, the square root of 10 could not be simplified any further. But the square root of 12 can be simplified further because there is a perfect square other than 1 that goes into 12. So I can write the square root of 12 as the square root of 4 times the square root of 3. You see, 4 is a perfect square. So this becomes 2 square root of 3. So the square root of 12, I'm going to rewrite using this. So I get 3x plus 2 equals plus or minus 2 square root of 3. Now, you see how I have a square root still in this part here? When I simplify the square root of 12, since 12 was not a perfect square, I'm going to end up with two irrational solutions. Okay? And so see that you're going to have 2. And for that one, we're going to do just like we did this. Just now here, now be careful. Don't say that these solutions are 2 irrational. They're not 2 irrational. Those are 2 complex imaginary solutions. So these are our imaginary solutions. You have that I in there. All right, but these are irrational. These are irrational solutions. It's not rational because 12 is not a perfect square. You still have that square root in as part of your expression on this side. So let's go ahead and subtract 2 from both sides. And so when I combine like terms, 2 and a negative 2 is 0. So I get 3x equal. Now be careful on this side. Some students have difficulty realizing that these two are not like terms. This is a negative 2. This term has a square root of 3. This does not have a square root of 3 in it. So you have to write it like this. You must say negative 2 plus or minus 2 square root of 3. And then divide both sides by 3. And then the 3's divide out. You get 1 here. 1 times x is x. You get x to be negative 2. So your solutions are these. Negative 2 plus 2 square root of 3 divided by 3. And then negative 2 minus 2 square root of 3 divided by 3. All right, and so you can list your 2 solutions in this compact form. Or in my math lab, you must say this. You must say negative 2 plus 2 square root of 3 divided by 3, comma, negative 2 minus 2 square root of 3 divided by 3. Okay? All right, so that is the key to the worksheet on Topic 5, Part B.